All right, my people. Came 102, Saturday, the 20th day of June, 2026. There is this rule before us. It's raining here, oh, it's cold, but I think I teach better when it's cold. What do you think? Now, class, follow me very quickly. There's a rule before us. This rule is called Markovnikov'S rule. Some people tend to bite their tongue when they call this man. Markovnikov'S rule. Markovnikov'S rule. Any day in UNN, you enter Chem 102 exam and you don't see a question in Markovnikov'S rule, walk out of that exam hall. You're in the wrong place. That must be common entrance exam. If it is Chem 102, then UNN must, not me, must ask you question on the man we call Markovnikov'S rule. Very long and delicious name. Now, I'll make life easy for you as usual. The way to remember this rule in organic chemo, Chem 102, is to say, make this statement. Follow me. The rich get richer. The poor remains poor. Let's take it again. Markovnikov'S rule to a layman states that the rich get richer. The poor remain poor. So if you're already rich, you will get richer. If you're poor, you remain poor. That is Markovnikov'S rule. Are you with me, somebody? Now let us relate it to the organic chemo. Now, this alkene compound, this is alkene. It's a member of alkene because of the presence of double bond. This is alkene. Precisely, we call this propene. 1, 2, 3. There are 3 carbon atoms here. 1, 2, 3. Propene. Now, some people can name this as prop1-ene. That's not correct. Please take note. Somebody can say prop1. Do you know why? If you number this 1, 2, 3, you see the double bond after carbon 1. So the basis of that, somebody can call this prop because I have 3 carbon atoms. And the person will not say prop1-ene, saying that there's a double bond after carbon 1. In fact, that is what it's actually supposed to be. Because when you're naming organic structure, you have to tell us the position of the double bond. But may I announce something to you? If a change in the position of the double bond, in fact, functional group in general, because the functional group I have in this structure is double bond. Now the rule says if a change in the position of the functional group, example double bond, a change in its position does not affect the nomenclature of the structure. Anyway, let's take it again. If a change in the position of the functional group does not affect the nomenclature of the structure, that means the name of the structure, we don't use number to indicate position. Do you know what that means? If you change the position of the double bond, for instance, if I move this double bond to this position, watch me. Now, I will no longer number from this place. It will no longer be 1, 2, 3. I will now number like this. 1, 2, 3. Because we must give the functional group the lowest possible number. That means if I'm coming this way, this will be prop 1. If I move the double bond from this position to this new position, that means I'll be going like this now, which still makes it prop 1. So whether the double bond is in this position or in this position, it remains prop1-ene. Therefore, it means that a change in the position of the functional group does not affect the nomenclature of the structure. Chem 102 says, under such condition, do not use number to indicate the position of the functional group. So instead of calling this person prop1-ene, I will just call it propene. I don't need to use number to indicate position. Reason, a change in the position of the functional group does not affect the nomenclature of the structure. So, but that's by the way. So this person here is called propene, not prop1-ene. Now, this propene you see here is said to be asymmetrical. 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 Please take note of this. Asymmetrical. It is not symmetrical. It is asymmetrical. Why? Now watch me. Follow me to the structure. This carbon here, the first carbon atom here, carbon 1. Watch the first carbon atom, carbon 1. Watch the second carbon atom, carbon 2. The two carbon atoms that are affected by the double bond. In this course, we call them alpha carbon atoms. The alpha carbon atoms are those affected by the functional group, which in this structure is double bond. So carbons 1 and 2 here are called alpha carbon atoms because they bear the functional group. I guess somebody is here. Now, this alkene is said to be asymmetrical if the alpha carbon atoms do not bear equal number of hydrogen atoms. See this carbon 1, the alpha carbon atom 1. It has 2 atoms of hydrogen. But alpha carbon, number 2, the second carbon atom, has only 1 atom of hydrogen. I hope somebody is here. That means that carbon 1 and 2 do not carry identical groups. It means that carbons 1 and 2, the alpha carbon atoms here, are not identical. They are not the same. They do not carry identical groups. Such a compound is said to be asymmetrical. But assuming the alpha carbon atoms carry the same number of hydrogen atoms, that means the same number and type of groups. If what I see in carbon 1 is also what I see in carbon 2, the organic compound will be said to be symmetrical. That is what we call symmetrical alkene. So alkene is asymmetrical if the alpha carbon atoms carry different groups. Beautiful. So now I have explained that this alkene here is said to be asymmetrical. Now Markovnikov's rule is saying that when you are adding hydrogen halide, like halogens, when they combine with hydrogen, they form what we call halide. So hydrogen bromide is a hydrogen halide, it's a halide. So when you say hydrogen halide, it can be hydrogen bromide, it can be hydrogen chloride, it can be hydrogen iodide. So if you have hydrogen halide and you're adding it to asymmetrical alkene, I'm discussing Markovnikov's rule now. The rule says that the hydrogen coming from the halide should attach to the alpha carbon atom that already holds greater number of hydrogen atoms. Hello, my people. This is carbon 1, this is carbon 2. Both of them, 1 and 2, are called alpha carbon atoms. Carbon 1 has 2 atoms of hydrogen, while carbon 2 has only 1 atom of hydrogen. Markovnikov's rule states that if you're adding hydrogen bromide into this structure, the carbon atom that will receive the hydrogen is the carbon atom that already holds greater number of hydrogen atoms. That's why we say the rich get richer. This carbon atom here already has more number of hydrogen atoms. It has 2, but this one has 1. So when you're adding hydrogen bromide to it, it is still the same carbon atom that already holds more number of hydrogen atoms that will receive the hydrogen of the halide. That is Markovnikov's rule. So it will affect the type of product formed. Now class, follow me. Look at product A. In product A, you see that it is carbon 1 that already holds greater number of hydrogen atom that receives the hydrogen, while bromine goes to carbon 2. So this is the right structure. This is the structure that is in line with Markovnikov's rule. This product here is called anti-Markovnikov product. Anti-Markovnikov product. That means it is not formed in line with Markovnikov's rule. Are you with me? But class, there is something. In every rule, there's what we call exception. And that is what UNN will always ask you. Watch me. It means that if I'm reacting hydrogen bromide with propene, I'm supposed to produce 2 bromopropene. 2 bromopropene. That means a bromo group should be attached to carbon number 2, giving you 2 bromopropene, not 1 bromopropene. The right product, which is the Markovnikov product, is 2 bromopropene, not this one. However, if this reaction takes place in the presence of hydrogen peroxide, H2O2, If they tell you that this reaction is taking place in the presence of hydrogen peroxide and the halide involved is still hydrogen bromide, beloved ladies and gentlemen, the acceptable product in this chem 102 under such a beautiful condition where the reaction is taking place in the presence of hydrogen peroxide will become the anti-Markovnikov's product. Therefore, if you go into the exam hall that day and they tell you that you're reacting propene with hydrogen bromide in the presence of hydrogen peroxide, the right answer will be 1 bromopropane. 1 bromopropane, not 2 bromopropane. Meaning that the acceptable product is the anti-Markovnikov's product. Woo! Did you understand that? You have to be part of this program, be it online or physical. Remember, we are resuming physical classes on Monday while online classes continue. Thank you.